Right, hi again, Year 9. I'm just going to continue now. If there's anything extra that I need to say, I'll just mention it during the question that I go through. So if there's a question that comes up where there's some more that needs to be said, I'll say it then. Okay? So question 1. Just get these colours sorted. Right. So what is the gradient of line A? So first of all, we actually have to identify that we're on about this line here. And it's just asking for the word gradient. Okay, so the answer is just going to be a number. Okay, just a number. Watching the first video from the playlist about the gradient would have made sure that everyone at least just wrote a number. Some people wrote down the equation, and even then they weren't writing the correct equation. So, but I'm just going to focus on the answer, okay? So basically, you must pay attention first of all to the scale, because sometimes the scale can try to trick you. For example, along the bottom it might be going 1 along all the time, but then up the y-axis it might be going up in 2s, for example. And so you have to be quite careful about the actual up and the actual along. However, in this question, it's a very straightforward scale because it really is just 1, 2, 3, 4, 5. It's just going up in ones, along in ones, and also up in ones. So you're just going to pick any 2 coordinates, and you're going to say how far along has it gone. So it's gone 3 along. There's nothing special about me picking 3 along, by the way. Absolutely nothing special about that at all. It's also gone 1 along and 1 up, or 2 along and 2 up, right? I'm just going to pick 3 along, because why not? So it's gone 3 along, and then how far up has it gone? It's gone 3 up. And 3 divided by 3 is 1. So the answer to this question was 1. Okay, if you put 1, you get the answer. Let me also just point out, I said it just before, let me say it again. You can really pick any coordinates you want as long as they're both on the line. So maybe I'm going 2 along and 2 up. But 2 divided by 2 gives the same answer, still gives you the answer of 1. So it doesn't matter as long as you are consistent. Okay, so the answer to this is 3 divided by 3, which is 1, or 2 divided by 2, which is 1, or 100 divided by 100, which is 1. The answer is 1. Right, number 2, what is the gradient of line B? So I'm going to pick, again, just 2 points on line B. Let's pick this point and this point. One question that normally gets asked, of course you can't ask me questions directly through the video, you can email me though or ask on Teams, but one question that does normally come up is how am I picking the coordinates? Is there anything special about where I'm picking them? No, there is nothing special about how I'm picking them. I just need to make sure that they are different, and then I try to make it easy for myself by picking nice coordinates. So what do I mean when I say nice coordinates? I just mean coordinates where it actually crosses at whole numbers. So, you know, I could pick this coordinate and this coordinate. Like, I could pick those. Of course I could. But I've made it much harder than it needs to be because I don't know exactly how far along and I don't know exactly how far up. So I'm going to pick some easier coordinates. And there are lots of choices. There's nothing special about me picking this one and this one, okay? Could have picked this one. Could have picked this one. Could have picked this one, okay? But I'm going to just pick these 2 because why not, okay? So I'm going to write gradient is up over along. So do the along first. Doesn't necessarily instantly make the most amount of sense. I can appreciate that because the along number is actually on the bottom and you normally taught, you know, you're thinking about the top of the fraction first. But it is a good idea to do the along first. So how far along have we gone? We've gone 2 along, and then how far up have we gone? Okay, so if you count that, it's 6 up. And 6 divided by 2 is 3. So the answer to this question is 3. It is also 1 along and 3 up. So again, a gradient of 3. What is the gradient of line C? Okay, so I'm going to pick 2 coordinates on line C. Let's pick these 2. I'm going to go 1 along. So remember, I'm going to write the gradient, which, by the way, I'm going to start writing M for the gradient. I know that might not make a lot of sense. Like, why would I not use G? It's just the letter M is traditionally used for the gradient of a straight line, so we're going to use it here. It's used all across the world. It's used in all the other schools in this country and in other countries. So let's just be consistent with that, right? So M is actually the letter that I'm going to use for the gradient. And I'm going to say M is up, over, along. So how far along have we gone? We've gone 1 along. How far up have we gone? Well, we've actually gone down 2. We've actually gone down 2. So that's a negative up, remember. That's minus up. So it's minus 2 up. So this is the thing that's a bit weird, right? If I said something is 2 meters down there, it's weird for me to say that it's minus 2 meters up there, isn't it? Like, you don't say that. However, within the context of this formula, we are going to consider it minus 2 up, okay, which is really 2 down. So in any case, minus 2 divided by 1 is just minus 2. It is going downhill, this line. So we need to make sure that that answer is negative. Okay, so that's a good little common sense check to do as well. Okay, line D, again, let's just pick 2 coordinates. Let's pick, say, this one and this one. Nothing special about the ones I've picked. I'm going to write M is up, over, along. So, okay, how far along is it? It's 1, 2, 3, 4, 5, 6 along and 3 down. So 6 along and 3 down is really minus 3 up. So I'm going to write minus 3 there. And then this simplifies to minus a half. Okay, it's minus because it's going downhill, and minus 2 is steeper than minus a half. If you're falling down a hill with gradient minus 2, you're going very, very fast and probably out of control. Whereas if you're going down a hill of gradient minus a half, it's still not particularly easy, but it's a lot easier than going down a gradient of minus 2, right? So it's all, again, it's all to do with how steep it is. Right, number 5. Now, this question, a lot of people got the automatic marking and they were told that they were wrong, and it's because the formatting of the answer was very specific. When I went through and manually marked everyone's, a lot of people regained this mark. For example, some people wrote, you know, top left and bottom right, and of course it automatically gave you that as wrong, but then I saw you'd written that and I marked that as correct because it is this one and this one. Let me explain why. Okay, so first of all, you need Y to be the subject. So this means you need Y equals and then something that just has X's and numbers in. Okay, number 2, you need it to be linear. Okay, so it can't have X squared or above in it. Okay, so this one here, this 2x squared add 3, is there to try to trick you because it looks like there's a 2 in front of the x squared and over here there's a 2 in front of the x, so it's like, are these parallel? Well, actually no, because this does not give a straight line. Let me show you what it does. It's actually what you're going to be moving on to is plotting quadratics. But let me just show you what it does. Okay, so y equals 2x squared add 3. Quadratics, which is when it's got the squared in it, when the highest power is a 2, give a sort of a U shape, not a straight line. And so basically, I won't go on into too much detail about this because, you know, I would actually be starting to talk about A level. But what I will say about the gradient of this sort of thing is it is varying. It is changing all the time. For example, down here, it's not very steep. It's not very steep at all. In fact, if you were stood right at the very bottom, you are pretty much stood on flat ground. I mean, not quite, but it is quite flat. And then as you start moving up, it's just getting steeper and steeper and steeper and steeper. So when you don't have a straight line graph anymore and you have something a little bit more complicated, the effect that that has on the gradient is that the gradient is always going to be changing. It's going to be getting more steep, or might be getting less steep. It might go flat. It might then go and point downhill, etc. So one of the key things about a straight line graph is it's the same amount steep everywhere. So if you're all the way down here climbing up, or if you're all the way up here climbing up, it's the same amount of difficulty for both people, if that makes sense, right? It's the same steepness everywhere. It never changes direction. It never gets steeper or less steep. And that is basically what defines a straight line, actually, okay? So yeah, I just thought I'd show you that actually this y equals 2x squared plus 3 is actually just there to completely trick you, to try to trip you up, because it's not a straight line graph. It's not a straight line graph. The rest are all straight line graphs. We need to make y the subject of all of them. So this one you need to add 2x to both sides. So this is y equals 2x add 1. This one I'll need to divide everything by 2. So y is a half of x plus 3. And so now the question is how do I know when some lines are parallel? So lines are parallel if they're pointing in the same direction, and that would mean they have the same gradient. That would mean they have the same gradient, which when y is the subject is just the number in front of the x. So we're just going to look for all of these. So we've got a 2, a 3, a half. This is technically just a 1. It's 1x, isn't it? 1x. This one we can just ignore because it's not a straight line graph. And this also has a 2. So it's this one and this one. And if you indicated that somehow with how you wrote out your answer, I awarded you that mark. Okay, so I went ahead and marked everyone's manually and changed the people who didn't automatically get the mark. Okay, right, number 6. A line has the equation y equals 4x add 7. What is the gradient of the line? So it's just 4. Okay, y is the subject and it's a straight line graph. It's not got x squareds or above in it, so it just means it's the number in front of the x. It's going to go 1 along and 4 up. We've got the same equation. What's the y-intercept? So this is when x is 0. When x is 0, you're on the y-axis. So I'll say that again. I said that in the overview video. I'll say it again. When x is 0, you're on the y-axis. And when x is 0, you'd have 4 times 0, which is 0. And then 0 add 7 would be 7. So the y-intercept is 7. You would have also got the mark if you wrote 0, 7, okay? Because, you know, are we talking about just a number or are we talking about a coordinate? It's not 100% clear, so you get the mark if you write either 7 or the coordinate 0, 7. Number 8. A line has that equation. What is the gradient of the line? So just be very careful, guys. The sign sticks to what comes after it, remember. That's minus 2x. So how many x's is that? It's minus 2 of them. So the gradient is minus 2. Let me show you what this graph looks like. So y equals 10 minus 2x. It has a downhill slope. It goes 1 along, 2 down, 1 along, 2 down, 1 along, 2 down. And if I put the numbers back on, we can see, okay, it's going through 10. And it goes, as I say, 1 along, 2 down, 1 along, 2 down, 1 along, 2 down, according to this scale. So that's that. What is the y-intercept of this line? So the y-intercept is -5. So we can think of this, I'm not saying it's the way you have to think about it, but you can think about it like this. That if I've got 3x minus 5, it's just the same as 3x plus -5. That's the same thing. And the plus c, whatever this is the y-intercept. So we are going through -5. Okay, number 10. What's the gradient of this line? So quite a few people write the answer 6. And of course it's because there's a 6 in front of the x. But what those people have forgotten about is that we need y to be the subject. We need it to just be 1y equals blah, blah, blah. Okay? Because it's 2y equals 6x minus 8, we cannot say anything straight away about the gradient. We cannot say anything straight away about the gradient, okay? Because what the gradient is for, a change of 1 in the x direction, what is the change that you see in y? And we can't say that straight away here. This would be the change in 2y, not the change in 1y. So I need to just divide everything by 2 to get started, okay? So this is y equals 3x minus 4. And now if I think about the gradient here, if I make x be 1 bigger, the overall effect will be that y becomes 3 bigger. It's just the number in front of the x, remember, when y is the subject. So the gradient is 3. What's the y-intercept? Well, this is the same as the previous question, so it's going to be -4, right? Not -8. We can only say about the gradient and the y-intercept, we can only say about these things when y is the subject. Okay? So you need to rearrange it to make y be by itself. Which I guess brings us on to question 12, right? We can say nothing about this yet. We have to make y be the subject. So 3y plus 6x equals 18. There's two choices here. You could divide everything by 3 and then take away, or you could take away 6x and then divide. Okay, so let's divide everything by 3. So y plus 2x is 6, and then take away 2x. And then the gradient is then just -2. Okay, it's just wanting the gradient. So the answer to that is -2. Right, number 13, we've got two different equations and it's asking, are they parallel? So we can't compare them until y is the subject. So this already has y being the subject, so that's good. This one, I'm going to add 10x. And then I'm going to divide by 2. And then you'll notice they both have the same number in front of the x. So they are parallel. Uh, 3y add 6x equals 18. Rearrange to y is -2x add 6, didn't it? So let me just copy and paste that and put it there. So when we've rearranged this to make y the subject, we can now say what the y-intercept is. It's just going to be 6. Or you could have written 0, 6. It's like that question from before where you could have written either. Number 15, what's the gradient of a line that passes through these two coordinates? Right, so this is where it starts to get a bit trickier, and where if you hadn't done those extra Hegarty tasks that were set towards the middle to the end of last week, you would have struggled with these questions. But again, I will point out, I have been available on Teams and through email the whole time. Now, there's been a handful of people who have gotten in touch to ask for help, and I'm quite hopeful that they found the help that I've provided beneficial and that it has been helpful. If it hasn't, then, well, I don't actually know if it hasn't, because you probably would stop getting in touch, I guess. But if I can be any more help, please do let me know, and I will try again and try harder. Like, that's fine. Just trying to make that as clear as I possibly can. Anyway, how do we answer a question like this? Well, it's asking about what the gradient is, so I'm going to write the little formula. And then we can actually have a think about what these numbers are, right? If I actually plot these coordinates, and this is where we would prefer to just have a nice little formula, which of course there is a nice little formula, but I don't want to confuse people too much. So I go 5, 9, which is about here. So 5, 9, and then 8, 18, which is there. And I've just done a little sketch. If you really cared about it, and you would really not need to do this, but if you really wanted to, you could get graph paper out and do that accurately. It becomes a bit annoying, of course, if the coordinates are massive or decimals or anything. So the question is what's the gradient of this line, given that we had 5, 9 was a point on it, and 8, 18 is a point on it as well. Okay, well, you work out the along, which, by the way, you can just do without drawing anything, because what do you do to go from 5 to 18? From 5 to 8. Well, how far along do you have to go? Okay, so it's 3 along, isn't it? And how far up do you need to go from 9 to 18? How far up have we gone to go from 9 to 18? This distance here will be 9 up to 18. Well, of course, that's 9 up, isn't it? And so, okay, what's 9 divided by 3? Okay, so it's 3. So the answer is just 3. So a little sketch can help you with a question like this. Let's try it again, this time with these coordinates. So -3, 4. Notice I'm not doing it really accurately. I'm just doing a little sketch, right? It's a little sketch. Doesn't mean I'm doing it accurately at all. And then 5, 8. Is there. And the question is what's this gradient? So the gradient is how far up divided by how far along. I don't know if you may be trying to remember this formula by now. It's really, really, really important formula. Really important. Hugely important. How far along have we gone? From -3 to get to 5, which, by the way, you could have seen just by looking at the coordinates. Okay, there was no need to actually draw a picture, but a picture can help. To go from -3 to 5, we of course go along 8, and that's the number that goes on the bottom, because the along number goes on the bottom. And then how far up do we go to go from 4, up to 8? From 4 up to 8. Well, that's just 4 up, isn't it? So if you actually put the along on, you get 8 along. If you put the up on, you get 4 up. Okay, I guess that should really be going through this here, right? But anyway, you get 4 up and 8 along, and so the m, which is the gradient, is just a half. Right, number 17, same idea. Let's again draw a little picture. We'll do the -291 first, just because I want to put the smaller x number first, if that makes sense, because I'm going to be going along left to right. So we'll be starting at -29. So -29 is there. And then 3 minus 1 is there. And the question is what's this gradient? So just crashed for a second here. Hopefully you're following this. Of course, if you're not, can you can you give me a specific time in the video that you don't understand and put that into an email so that I can help you? Don't just tell me you don't get the whole thing. Can you be specific about what part is it that you start to not understand? So anyway, gradient is up over along. So the along is, how far along is it to go from -2 to 3? Okay, well that's 5 along. And how far up is it to go from 9? Because remember, we are starting here, remember, and going left to right. So we're starting here and going downhill. So to go from 9 up to -1, of course we're going down 10, aren't we? So that's -10 up. So -10 shared by 5 is -2. Right, number 18, we're nearly done. Find the equation of a line that has gradient -5 and passes through the point 3 -1. Okay, so the equation of a line looks like this. We want to know what M is, and we want to know what C is, and if we knew both of these things, then we'd have our answer. We know what M is, so I'm going to put that in straight away. Now the question is how do we figure out C? Okay, how on earth do we figure out C? Well, we use the other bit of information, okay? When x is 3, we're supposed to have y is -1, because for this point here to be on this straight line, it satisfies this equation. So you substitute in the coordinate into the formula. And what that's going to do is tell you exactly what C is. So let's see what we get. Instead of y, I'm going to write -1. And instead of x, I'm going to write 3. So -1 is -15 plus something. So C is, I guess, 14, right? If you add 15 to both sides. So you should have y is -5x plus 14. Number 19, a line goes through the points -10, -5 and -7, 4. What's the equation of the line? Right, so we know the equation of the line looks like y equals mx plus c. We have to figure out m and we have to figure out c. Step 1 is to figure out m, right? Because the second step is always basically to do that substitution and work out what c is at the end. Now in the last question we actually got told what m was. In this question we don't know what m is, we have to figure it out. But we can figure out what m is, because we have to go along from -10 to -7 and up from -5 up to 4. And once we know the up and the along, we can figure out the gradient. So m is up over along, which is going to be, how far along is it to go from -10 to -7? 3 along. How far up is it to go from -5 up to 4? 9. 9 divided by 3 is 3. Oh, so we've been given, or we weren't given, but we figured out the gradient. So now I'm going to write y equals 3x plus c, and I'm going to do step 2, which is to substitute in either of these points, because we know what a coordinate is that's on this line. So let's pick -10, -5, because why not? So when x is -10, y is -5. So what do we get? -5 is 3 times -10 plus c, which is -5 is -30 plus c. So c is 25. So y equals 3x plus 25 is our final answer. And what we would do is we would do a little check. You would check that this works for the other coordinate that we didn't use for finding c. So when you do 3 times -7, you get minus 21. So this part here is minus 21. And when you add 25 to minus 21, you get 4. So this definitely works, and we haven't made a mistake. That's the answer. Right, last one. Half an hour in, so I'll try to do this quickly. So what we want is we want y equals mx plus c. We want to know what m is. We want to know what c is. So for m, I'm going to do up over along. I'm going to start here because we're starting with the smallest x number and going along to the bigger x number. So that means we will be going left to right. Minus 2 to go along to 3 is 5. And then up to go from minus 8 up to 7, that's 15. So we have m is 3. So y equals 3x plus c. So we've done m. Let's figure out c. Let's do 3, 7. So 7 is 3 times 3. Add c. So c is minus 2. So y equals 3x minus 2. We'll check the other one just to make sure it works. 3 times minus 2 is minus 6. Take away 2 is minus 8, so it works. Right. If there were any parts of this that you struggled with, there are tasks on Hegarty Maths that can help you. There are videos on Hegarty that can help you, and you can practice the same skills. It would have been better to do that during the actual lessons of last week before the assessment, but when we eventually come back to school, I will expect you to know this. I will expect you to know this. So you have to ask for help if you are stuck. You don't have to do that on Teams. You can do that via email. And, well, yeah, there's not really a lot else to say. Specific questions are better than general ones. So if you look and find a timestamp for the video and say, sir, I didn't understand this exact part, this exact line, can you explain where it came from? That's way easier for me to help you with than a really general, massive question that is going to be quite tricky to answer in an email. Okay, so hopefully that's helped. Sorry the videos were so long. I did try to do it as quickly as I could, but it's just hard to do the whole thing, basically the whole topic in less than an hour, but I've tried very hard. Right, see you later guys, bye bye.